Right. Hello, everybody. Good afternoon again. Welcome back to our webinar series. We've been doing this for many weeks now, and it's always a very thoughtful and a very thought-provoking discussion that we have here with our panel. And we of course are looking to replicate the success with every subsequent series. For those of you who are joining us for the first time, please feel free to log on to YouTube and the previous sessions. All our sessions are now live. And today we are going to talk about computer vision. Computer vision, as some of us know and some of us don't know, is the ability of deriving meaningful information from digital images, videos, and other visual inputs, and take actions based on that information. AI has been enabling computers to not only do but also to think, and computer vision further enables them to see, observe, and understand. My name is Dipit Sharma. I serve as the Director for Alliances and Partnerships at FirstUniv and your moderator for today's session. And today we welcome back Dr. Gaurav Gupta. Dr. Gaurav Gupta has helped us before understand the complicated or the not so complicated world of AI and machine learning. He's a III senior member and currently serving as an assistant professor at the Yogananda School of Artificial Intelligence, Computers and Data Science, Faculty of Engineering and Technology at Shulan University in Solan, Himachal Pradesh. He also teaches and does a lot of research in machine learning in different domains, especially in healthcare and agriculture. Dr. Gupta received his engineering degree in BE in 2006 from B.R. Ambedkar University in Agra. In 2011, he got his PG, and in 2019, his PhD degree in the stream of computer science engineering from KSOU, VIT Karnataka, and Shulani respectively. In addition to teaching and mentoring, Dr. Gupta is also a published author of 12 plus books with local and international publishers. He also guides a lot of his students, helps them understand the subjects, and of course, choose a career path. Welcome back, Dr. Gaurav. We are so happy to have you. And
thank you, David.
Without further ado, I'll pass over the reins to you. Thank you.
Thank you, David, for the lovely introduction.
My pleasure.
Welcome back to you all. Today's topic is computer vision. We have last talked about the machine learning in healthcare. Today we are talking about what is computer vision, why computer vision is into existence. So what is computer vision and nearby fields? Computer graphics is the main motive of the computer vision, like models to images. And what is the image processing, like images to images? These are the basic differentiate between why computer vision and what are the basic behind the computer vision. Starting with the computer graphics, image processing, and now the computer vision. It is a blend of both computer graphics and image processing, like when we convert images to our models, then the technique is known as computer vision. What exactly a computer vision? Make computer understand image and videos. That is known as computer vision. What kind of scene is this? You are looking at a picture adjoining this text. What kind of scene is this? This is like a home, a house is there, a plant is there, something. Where are the cars? How you identify in this particular scene, where are the cars and how far is the building? That is the main perspective of computer vision, to analyze each and every image of that particular scene. If we are talking about the cars, there are 3 cars in the picture. There are one house, a fountain, a flowers, and clouds, and etc. So vision is hard. Why vision is hard? Vision is an imaging feat of natural intelligence. Is that a queen or a bishop? A man is standing in front of a chessboard and he's saying, is that a queen or a bishop? Visual cortex occupies about 50% of MARQ brain. More human brain devoted to vision than anything else. Why computer vision matters? What are the main motives of the computer vision? Why it matters a lot? Because in today's scenario, we need safety. It uses in health, security like CCTV cameras, comfort zone. The fun part means animated games, the 3D games, all comes under the computer vision, and access to different type of images in today's world. That all comes under computer vision. All these scenarios comprises of what we are talking about today. Topics is that is computer vision. Why and what are the application of computer vision? Why we need computer vision? What is the need of computer vision? You all know what are the autonomous vehicles, why there is a need of computer vision in autonomous vehicles, surveillance, factory automations, medical imaging, human computer interactions, and visual effects. Why do we need to study this field apart from curiosity to understand the world, apart from the need of the computer to what humans do? What are the application of computer vision in today's world? These are certain application like autonomous vehicles. What are the, I am quite sure many of you may already know this, but computer vision is all around us today. Be it face detection on your Facebook or Picasa or any other platform, or to autonomous vehicles where the perception in front of car is through various cameras, including camera like LiDAR camera. Surveillance, the second part is surveillance as a CCTV in your airports or railway station or wherever it may be. Factory automations. This is the one of the oldest application of computer vision where cameras are fixed in various settings in manufacturing pipelines or warehouse to be able to automate various aspects of factory. Factory cases, medical imaging, very important applications today. Human computer interaction. This is the future. This is upgrowing field, upcoming field. Some of you know may have played with Kinect or Xboxes where there is a stereo camera looking at a user and tracking the user to say whether a user is playing or not. If the user is playing a bowling game or a tennis game, whether the movement is a particular forehand or backhand or any other movement for a particular game. And finally, visual effects and movies where computer vision is used extensively. There are just some example application of different domains, but you can imagine that on the feed that you get from the camera to be able to get knowledge using in an automated manner. Application of computer vision in to be continued. These are the various application, more application like retail and retail security, healthcare, agriculture, banking and finance, remote sensing, structural health monitoring, document understanding, tele and social media, augmented reality. We will take one by one. In fact, one of our homework is so that particular lecture is going to be click on some of these links. You can go and study more about these things on the particular links we have given in this. And I can on the on the retail and the security aspect, what are this one? Some of you may know have heard of Amazon Go, an initiative of Amazon, where the entire shopping experience is without a billing counter. I think you all know. So you go into a store, pick up where whatever objects you want to, and have a difference on the different shelves, and you simply walk out of the store with no billing. So the retail store automatically tries to understand what objects you have picked and put into your basket and just deducts it from your Amazon wallet or any other thing or any other wallet that you configure with your shopping experience. Similarly, the virtual try on, where you try on a piece of cloth before buying it online and try to see how it looks on you. Same is the example with Lenskart. There is a company known as Lenskart which sells spectacles, goggles, and you can, with the help of AI or computer vision, you can have a number of uh, goggles on your faces before buying the one. Healthcare, where you can use it for blood loss detection, dermatology, in agriculture for trying to find out various aspect of agriculture, for trying to find out livestock face recognition, in banking and finance to be able to deposit your checks automatically through a feeder. This is the future. This is the coming scenario. Means all the banking will be a vision based. So there is no human involved in trying to find out to whom the check should be credited and what the amount of all that is automated through various systems. Insurance risk, risk insurance risk profiling. How it works? Remote sensing, where do you land use understanding your using satellite imagery, or forestry modeling using drone or satellite imagery. Structural health monitoring, a very important application today where you can do oil well inspection or drone based bridge inspection, or 3D reconstructing or trying to understand the health of railway tracks using drone imagery. This is extremely important in various settings where you may want to monitor the health of infrastructure without to physically inspect the infrastructure. Means you are not going physically over there, you are just going visually over there and inspecting all the monuments or railway tracks and something else. For example, it may not be trivial to under a bridge and try to find out if there are cracks under the bridge, but you could use a drone to fly through that area and use the image that you get from drone to be able to process and understand the health of the bridge, railway tracks, oil refineries, and many of those are on those large infrastructure. Document understanding, this is also important. We will deep dive into this one. Optical character recognition, robotic process automation. Optical character recognition is one of the oldest success of computer vision. In fact, one of the oldest products that computer vision has delivered to the world. Robotic process automation for documentation understanding. You can click on the links to understand what each of these term means. Tele and social media, image understanding, brand exposure analytics. Augmented reality, to be able to do visual support to the warehouse, and enterprise management, and so and forth. In case of any of these terms are not clear, please do click on these links and each of these links will be able to go you the descriptions or more information about these links. What I am talking about, optical character recognition. This is the part I am talking about. How optical character is recognized. This is the particular how it is recognized from n number of sources. These are n number of sources and we are recognized one by one, 4, 5, 6, 7. These are the digital recognition ANT labs. And this is license plate reader 4 by CH 28. This is the how automatically your license plate is read out. You have seen various computer cameras or infrared cameras are now put it on the highways, and you get challaned if you are on the overspeed or on the wrong side or something else, and your plate is automatically deducted from the amount. And same as with the fast tag, it is a computer vision technology. It is getting your number plate or it is getting your fast tag barcode, and it is your your amount is deducted automatically. Face detection. You all have seen this in your mobile phones, cameras, and something else. Many new digital cameras now detect faces. Canon, Sony, Fuji. This is about cameras, but now your mobile phones are detecting your face. Emotion detection. This is the new technology, how the emotion is detected. Imagine a camera smart enough to catch every smile. In smile shutter mode, your cyber shot camera can automatically trip the shutter at just the right instant to catch the perfect expression. Means this is the one first picture in which the kid is not smiling. This is the second smile captured. It will automatically click the picture. Here also, it will automatically click the picture. Here, it will not click the picture as the camera is not seeing any smile on this image. Here, it is clicking. Here also, these two pictures are not able to give any type of smile because we have put the camera on a smile shutter mode. This is the image. In which image you are getting the smile, it will automatically click the image. 3D from thousands of images. This is the image. How this is thousands of images, and we are making 3D model out of those images. You can see these are the short pixels, or these are the small images, and we are when combining all together, this is the whole image. This image is the whole image. You're seeing this as a whole image. Object recognition in supermarket, how it can be worked. It is given by Lane Hawk by Evolution Robotics. A smart camera is first mounted in the checkout lane. This is the camera which is mounted in the checkout lane, continuously watching for items. It is watching for item, what which type of items you have taken, what amount of item you have taken. When an item is detected and recognized, the cashier verifies the quantity of items that were found under the basket and continues to close the transactions. The item can remain under the basket, and with Lanehawk, you can assure to get paid for it. These are the types of computer vision. You all seen these two images. This is the how the Afghan girl was identified by her iris pattern. You can read her story on Wikipedia. How it is identified. This is a younger photo, and this is the photo of now. Biometrics. We are talking about biometrics. This is all the application of computer vision. We have scan her eye, the retina scan. You are also going for a retina scan. This is her previous image, and this is her now image. The retina will be the same. There is no difference in the retina. That's why we are identifying her in so many years also. Login without a password. This is also a computer vision. Fingerprint scanner or many new laptops, other devices. You are not logging with password. It is a scan image. It is scanning your image that are previously saved in your devices. As you use in your mobile devices, the finger scanner, you just before opening the mobile phone, you just make your finger scan to a particular. It get captured your images, and if uh, when you try to open the mobile devices, you just recognize those fingerprints, those images into that one. Face recognition system now being to appear more widely into the mobile phones. You can open your mobile phone with your face face recognition, even your windows also. If you identify your face, it will open automatically. Special effects, shape capture, how you are capturing the shape. All you have seen the movie name Matrix, the Matrix movie from ESC Entertainments. This is the face of the man. You are seeing the n number of faces here. This is one, this is one. There is only one man, and how we are creating this illusion with the help of special effects. That is all done by computer vision. We are just extracting one images and putting it into a number of frames simultaneously. With all these things with the help of machine learning or AI, not without that. You have seen the Pirates of the Caribbean, Industrial Light and the Magic, how it has been shot. This is motion capture, how you are capturing the motion. This is the face of the man, and this is the face of original man who is depicting this role there. He just, you can see the emotion. We are just morphing the image over his face and capturing the emotion. These are the special effects, a part of computer vision. Sports, you can see in the sports vision down the line, computer vision is using uh, actively use, we are using actively using computer vision in sports. You can see the DRS system in the cricket. You are seeing here how it is pulling the leg of a one fielder. It is a penalty, and by this help, it will help the referee in taking quick decisions. Smart cars. Our vision, your safety means rear looking cameras. There are n number of cameras nowadays, n number of sensors in smart cars. Rear camera, front forward camera, side looking camera, down on the rear mirrors. This all done by IQ vision on the chip. This is the one. Vision application, road, vehicle, pedestrian protection, and more. AWS, it not related to cloud, it's related to advanced warning system. Means how much distance is between the two cars, what are the obstacles nearby. This all comes under computer vision. Okay, Volvo cars are nowadays, Volvo is the leading partner in this one, but now many of the giants have come up with this vision technology. Also, the Google car, the driverless car. That is a smart car. This is a driverless car. It all works on the pattern of computer vision. These are the cameras, these are the radar over the head, and these are the camera which are capturing the scenario in front of this one. Vision based interaction, how you interact, how you play the games. These are the three examples I have picked from the net. Nintendo Y has camera based IR tracking built in. Means on clicks, clever tricks on using it to create a multi-touch display. It will create a multi-touch display from one single display. Game turns moving into human joysticks. N number of players are playing with only one game. N number of players. You can see the N number of players are sitting here and they are playing one game over there one. And Digimask, put your face on a 3D avatar. This is the face and these are the Digimask. You are no, you have seen this type of application in your mobile phones or something somewhere else. Interactive games, Skynet. These are the interactive games. You have played Xbox or something like table tennis or shooting ranges. That are the interactive games which are available right now. 3D games. AR VR is also a computer vision example in which you feel like you are into the scene. You are not outside of the scene. You are into the scene. You are working into the scene. Vision in the space. This is the future. How the Mars operation. India has done the Mars operation. US has landed a rover over there. NASA Mars exploration rover split captured this westward view from atop. This is the picture from 2007. You can see how the computer vision is working in 2007, and it is more enhanced feature in 2022. Vision system means JPL used for several tracks like panorama stitching. How you are getting the panorama stitch. This is the panorama stitch. This is not a one image. It is a bundle of images. It has taken into the moving, into the motion. You as you take the panorama in your mobile phones nowadays. 3D terrain modeling. It is the image like 3D image. It is while capturing the panorama stitching, it is also capturing the 3D terrain of that particular mass object. Obstacle detection. While making the 3D terrain, it is also detecting the object. Where is the particular rock is there, path is there, or something else in between the path. Position tracking. Where is the exact location of that obstacle? You can read more from Computer Vision on Mars by Mathis et al. This is the article I have taken from the famous researcher, that is Mathis. You can go and search over this one and you can read more over there. And mobile robots. All are fascinated with robots. How these are working. What is the technology behind these robots? Means NASA Mars Split rover. You can see this one. This is the Mars Split rover. This is the robot which is helping in daily working, the cleaning of utensils, cleaning of walls, keeping the utensil into the particular rack cases. This is the NASA rover, Spirit rover. This is the best example of computer vision technology, including hardware and technology and AI machine learning into the part. This is the particular example. from here there are a number of sensors, but here are the cameras. It is getting the vision. You can see there is an obstacle in front of the tire of this rover. How it is going to handle this one? Either it is going to over from this rock, or it will change his direction from that rock and proceed further. This is the state of Stanford. Means these are the robo dogs which are playing football. Means playing with the ball. These are the robo dogs made by Saxena et al. This is an Indian who has made this one. Still at Stanford, who is working in Stanford. That is the researcher. And the most important, that is the medical imaging. Robot computer vision is working. Researchers are working tremendously into the field of medical imaging. Here, what is this one? It is the image guided surgery. Image guided surgery means on the part of robotic, it is robots are performing the surgery over the patient, and the doctor is sitting far away and it is performing the surgery here. And 3D image MRI CT. Before, you have seen there are x-rays which are in black and gray or black and white. You can't see exact what is the pinpoint of the diagnosis. But now 3D image MRI CT, you can see inside the brain the colorful picture of the brain, and you can diagnose easily. How we can diagnose the things? That's all from my side for today. This is open for question. Dipit. This is the brief introduction of computer vision, how we are using the computer vision in today's scenario.